Hello guys, my name is Craig. Welcome to Peri Solutions. And if you're new here, please subscribe and hit the notification bell so that you don't miss out on my new videos. Today we're going to look at module 2 of the differentiation series, and this is looking at stationary points and their nature. So to start off, we shall look at what stationary points are, and to do that, I've drawn a curve for you here. The curve of the function y is equal to f of x, which you're going to use. So from this curve, we want to study what happens to the gradient of this curve at the points A, B, C, and D. So to start off, let's study what happens to the gradient of this curve at point A. At point A, for this curve, the gradient function dy by dx being equal to f prime x. So now, we see that at point A, as x increases, the function f of x also increases. So this means that the gradient of the curve at point A is positive, and therefore, at point A, this function is an increasing function. Now at point C, what do we see? We see that as x increases, the function f of x decreases. So now what does this imply? This implies that the gradient at point C is negative, and therefore at point C, this function f of x is a decreasing function. Now let's study at point B. So allow me to just write at B. So dy by dx, being the gradient, we know is given by the change in y over the change in x. So now at B, what is the change in y? So the change in y there is there. But what do we see? There is no change in y because the change in y is 0. So we are saying 0 over whatever change in x that we decide to have. But this will still give us a 0. So at point B, we see that the gradient of the curve y is equal to f of x is equal to 0. Now we can do the same study for point D and say at D, so at point D, dy by dx, being the gradient function, is given by the change in y over the change in x. So at point D as well, from the tangent we see that the change in y is there, but there is no change in y because dy is still just remaining there. So the change in y will be equal to 0 over whatever change in x that we decide to have, and this will still give us a 0. So now what do we see from these two points, B and D? At points B and D, the gradient of the curve y is equal to f of x is equal to 0. So now what does this mean? This means that at points B and D, the function y is equal to f of x, it is neither increasing nor decreasing, but it is just momentarily at rest. So now these points B and D, these are what we call stationary points. So now what's there to take note of, right? So at a stationary point, we see that the gradient is equal to 0, or we can say the gradient function is equal to 0. So now this is the first note that we shall take note of. So at stationary point, dy by dx, or f prime x, which is the gradient function, is equal to 0. So now this is the first condition. At a stationary point, dy by dx, which is the gradient function of whatever curve that we have, is equal to 0. Now the second condition that we can come up with is, you can see with those tangents that we use to calculate the gradient at the specific point, with the tangents at B and D, these two tangents, they are parallel to the x-axis. And we also know the x-axis is the line y is equal to 0. So now what can we conclude about this? we can conclude that the tangents, they are also parallel to the x-axis. So the tangents at the stationary point, tangents are parallel to the x-axis. So now, which we said is also the line y is equal to 0. So these are two very important conditions to take note of when we are talking of stationary point. At a stationary point, dy by dx, or the gradient function, is equal to 0. And as well, the tangent or tangents at stationary points, they are parallel to the x-axis, which is also the line y is equal to 0. So now I would like to look at an example that requires us to find the coordinates of the stationary point. Allow me to erase this. Okay, so we've got y is equal to x to the power 3 minus 2x squared plus x minus 0. Okay, so now we've got this curve, the curve of y is equal to x to the power 3 minus 2x squared plus x minus 7. And the question requires us to find the coordinates of the stationary point. So this is what we're going to simply do. We said at a stationary point, the gradient function is equal to 0. So our first task is to find the gradient function for this function, which is dy by dx. So dy by dx will be equal to, now we shall differentiate term by term. The derivative of x to the power of 3, we are dropping the power 3, multiplying by x, then subtracting 1 from the power of the 3 that is already there to get it 2, minus 2 times the derivative of x squared. We are dropping the power 2, multiplying by x, then subtracting 1 from the power of the 2 that is already there to get a 1, plus the derivative of x. This is x to the power of 1. So we are dropping the power 1, multiplying by x, then subtracting 1 from the power of the 1 that is already there to get a 0. And the derivative of 7 is a constant. So we know we simply get a 0. So now let's proceed to simplify this. This will give us 3x squared minus 4x plus 1. Because we know x to the power of 0 is just 1. So now this is the gradient function. But we know at a stationary point, this gradient function should be equal to 0. So now the next step would be to equate this to 0, then solve for x. So we are now saying 3x squared minus 4x plus 1 is equal to 0. Then solving for x, we're saying 3x squared minus 3x minus x plus 1 is equal to 0. Then from this two-term expression, we can factor out 3x to get x minus 1. Then minus from this two-term expression as well, we factor out minus 1 to get x minus 1 being equal to 0. So now we can have x minus 1 then 3x minus 1 being equal to 0. So now we can say either x minus 1 is equal to 0 or 3x minus 1 is equal to 0. Then find two values of x. So now x minus 1 is equal to 0 or 3x minus 1 is equal to 0, such that x is equal to 1 or 1 over 3. But remember, we want the full coordinates of the stationary points. So now for these, using these values of x, we shall find the corresponding values of y. Such that we say when x is a value of 1, what is the value of y from the original equation? And when x is a value of 1/3, what is the value of y from the original question as well? From the original equation as well. So now when x is 1, we've got y being equal to 1 to the power of 3 minus 2 times 1 squared, then plus 1 minus 7. This will give us 1 minus 2 plus 1 minus 7, which will give us minus 7. So now for the first stationary point, we've got 1 minus 7. 1 minus 7. And then now to get the second stationary point, we shall find the value of y when x is a value of 1/3. So when x is equal to 1/3, y shall be equal to 1/3 to the power of 3. So 1/3 to the power of 3, then minus 2 times a third. So minus 2 times a third raised to the power of 2, then plus a third, so plus a third, then minus 7. So now simplifying that, we shall get y being equal to 1 over 27 minus 2 over 9 plus 1 over 3 minus 7, which will simplify to y is equal to minus 6 and 23 over 27. Like that. So now, this is the value of y when x is a value of 1/3. So now the second stationary point would be 1 over 3 and minus 6 and 23 over 27. So these are the two stationary points that we have. These are the coordinates of the stationary points. Now we shall move on to look at the nature of stationary points using the very same example. So allow me to erase this part. Just write nature here. Okay, so now for the nature of stationary points, we have to use the second derivative. dy by dx is the first derivative. D squared y by dx squared becomes the second derivative. And then for us to get the second derivative, we simply differentiate the first derivative. So dy by dx is the first derivative. Then d squared y by dx squared is the second derivative. Okay, so now there are conditions that we use when we want to determine the nature of a stationary point. So the first condition is that when the value of d squared y by dx squared is less than 0, we say that the point is a maximum point. So point is maximum. This is the first condition. The second condition, we say that when the value of d squared y by dx squared is greater than 0, we say that point is minimum. Then the last condition, we say that when the value of d squared y by dx squared is equal to 0, we have a point of inflexion. Point of inflexion. So now, these are the three conditions that we use when we're talking about the nature of a stationary point. So now, what we'd like to do is to find out about the nature of these two stationary points whether this is a maximum or minimum, and also whether this is a maximum or minimum. So allow me to erase this part. Okay, so the two stationary points, we've got 1 minus 7 and 1 over 3 minus 6 and 23 over 27. Okay, so I shall erase this as well. Okay, so now for the nature of stationary points, we said we need to use the second derivative, which is d squared y by dx squared. So from the original equation, it means that we originally need our dy by dx, which we calculated to be 3x squared minus 4x plus 1. So now the second derivative, we're going to differentiate this first derivative. D squared y by dx squared shall be equal to 3 times the derivative of x squared. We're dropping the power 2, then multiplying by x, then subtracting 1 from the power of the 2 to just get a 2x, minus 4 times the derivative of x to the power of 1. We're dropping the power 1, multiplying by x, subtracting 1 from the power of 1, we get to the power of 0. Then plus the derivative of 1. If we differentiate a 1, since it's a constant, we know we'll get a 0. So now we go further to simplify this, and we'll get 6x minus 4. So now this is the expression for the second derivative. Now we want to find the nature of the first stationary point, which is point 1 minus 7. We shall say when x is a value of 1, what is the value of the second derivative? So when x is 1, let's say we've got 6 multiplied by 1 minus 4. In 6 minus 4, we get a 2. What do we know about 2? 2 is a value that is greater than 0. And we said for a value of the second derivative that is greater than 0, we have a point, minimum point. So this definitely is a minimum point. Okay, so now let's find out the nature of the second stationary point when x is a value of 1/3. So we shall say when x is equal to 1/3, what do we have? We've got 6 times 1/3 minus 4, which will give us 2 minus 4, we get a minus 2. And you know minus 2 is a value that is less than 0. Minus 2 being less than 0, we said for a value of the second derivative that is less than 0, we have a maximum point. So now this is a maximum point. Okay, so this was module 2 of the differentiation series. So please don't forget to leave a comment, drop a like, and subscribe. Thank you.